All right, a very warm welcome to today's session where we are going to see what exactly is an AWS load balancer. So far we've seen many topics like what is an EC2 server. We've seen in detail about what is VPC. We've seen about internet gateway, NAT gateway, subnets, and everything. But today we're going to learn about an interesting topic which is used widely in the AWS in corporates in different enterprises. So what does a load balancer mean? That's what we are going to understand today. So there are different types of load balancers, and what do they exactly do? That's what we are going to understand. So let's say in our previous videos, we have understood that I can host any type of application or a website on a particular server. So we've seen it on a Windows server. So we went into a Windows server and we configured the IIS, which is the Internet Information Services, to host a particular website, right? But at the same time, we can do the same on a Linux server as well using other ways. So at present, in order to understand this, we're going to use a Windows server again. So let's say that I have a Windows server here, which I've created on AWS. So that service to create a server is called as an EC2, which is Elastic Compute Cloud. So if you want to understand that, you can check out my other video where I explain EC2 in detail. So EC2 service in AWS is used to create servers, right? So let's say that we create, for example, one server where I have a Windows server. On that, I have configured a web server and I'm hosting a particular website on that. Now, the capacity of the server determines how many people will be able to access that website at any given point. So I'm sure many times we've seen different cases where at a particular given time the server gets overloaded. So let's say that there is a particular let's say that there is a particular event happening. For example, let's say that it's a university website or a college website which is issuing the students result on a particular day. So of course there will be an overwhelming number of students who will be accessing that server, which does not happen usually, right? So it operates at a much higher capacity than usual. So on a day when every student is trying to hit to the server to check the results, of course the server will be overloaded and it will not give you the results. It will just hang up. And we see that in many different types of public services also. On a particular day, let's say many people are trying to book a particular train, when the slots open at a particular time, we know that the servers will hang up. Only a few people will be able to get in, but the others will get stuck because the servers hang up, right? And same is the case with earlier it used to happen that many of the e-commerce websites, if they have a sale or something, the number of people who would be accessing the website at that particular time will be much higher than the usual number of people who access it, right? So of course, because of the technology that we have these days, we don't see any of the e-commerce websites majorly hanging up because they have the necessary provisions in place. And that is exactly what we're going to learn today. How do they manage when a more than regular number of people are accessing a particular website or application? So let's say that this is my server. Let's say that this server has 8 GB of RAM and let's say some 8 virtual CPUs or something. Okay, so this is the configuration of my virtual machine, right? Every server will have a certain capacity. Of course, the servers that we use generally will have a lot more capacity than this, but this is just an example I'm taking. So let's say so on my system, if I show to you, this is a Windows system that I'm using. And if I go to the task manager, which I can access from the taskbar here. So if I go to the task manager, I see that the CPU utilization on an average at present is at around 8 to 10%. Okay, so that's the range that it is hovering at present. And the memory, I have about 16 GB of memory on my system, and it's using about half of it consistently, right? And there are other performances as well which are being monitored. So at present, if we look at CPU and memory mostly, this is the range. But if I run any particular application or my system is being used for some application or website access or something like that, then the CPU will go much higher than this. What if even if I run certain application now, the CPU will go much higher than this, and the memory also. So we all know that, right? So this system will have a certain capacity. Let's say if 1,000 people are accessing the website which is hosted on this server, let's say that the CPU utilization goes up to 70%, right? And memory also goes up to 70% or something. And let's say that after that, whenever the number of people start joining in and try to access the same website, the CPU utilization will keep on rising, as well as the memory utilization. So at a particular point, let's say that around 1,500 people have connected to the website now. So at that time, the CPU utilization will go above 90%, right? 95, 98. So when it reaches that peak utilization, then the system will start to give up. It will just slowly decrease in performance, and it will start to hang up. And that's the exact result that we see in many cases, that like we have discussed. So what happens is, in these kind of cases, you cannot rely on just one server, right? So for example, we've seen one server hosting a website, but that's majorly never the case whenever you're hosting a website, because one server itself cannot handle the load that will be put on that application when many people are accessing. That's one reason. And the second reason is also that you cannot rely on just one server. Let's say that you have one server, there is some issue with that server, and it just hangs up, or it shuts down or restarts for some reason. Then at any given point, your server will not be available, and whoever is trying to access your applications, they will not be able to access it. They'll get a page not available error or something like that. So we do not want that kind of a scenario for our business or any business, especially when there are certain critical applications running on that server, right? So that's why you never rely on solely just one server. We always have at least two servers or more, right? So that is the exact reason where we require a device called as a load balancer. So if we take up the example, let's say that there is a e-commerce website, a very large e-commerce website. Let's say that's it's something like Amazon. So in every different country, Amazon always has its annual sale, or wherever there is an important festival or something, they'll definitely have certain kind of sales, right? So it's fairly understandable that if they have a particular sale on a particular day where they are giving a huge amount of discount, let's say 20%, 30%, 40%, the number of people who would be waiting for that sale so that they can make a purchase will be very high, right? Because they'll all want to make some savings. So in those cases, it is predictable that the number of people who will access that website will be much higher. So let's say that any example like Amazon.com or whatever different e-commerce websites we have, let's say that on general days there are, I'm just giving an example, let's say that there are 10 million people who are accessing it every day at any given point. So on a festive day or something, let's say that it rises up to 20 million people who are accessing it, right? So if 10 million number of people are exactly using, let's say, 100 servers, just an example, and anything more than that cannot be handled by the 100 servers, then for 20 million people, how many servers would be required? So of course we know it will be 200 servers, right? So if 10 million is handled by 100 servers exactly, then safely, then it will be 200 servers that we require for 20 million users, right? So keeping that in mind, we need to understand that how will you manage these number of servers, right? So if you have 10 different servers, you need to make sure that equal number of people are distributed to equal servers. So let's say I have one server here, and let's say I have an exactly same server here as well, right? So I have two servers. Now if I have let's say I have 500 incoming customer requests to access the website, I have to make sure that I send the exact number of requests to each server. So out of this 500 total number of requests, I need to ensure that 250 go to this server and 250 go to this one, right? So we need to ensure that the load is equally balanced. So only the load can be balanced only if you have a distribution point, right? So let's say that here 250 users are coming in here. So how will we ensure that the equal number of requests are going in? So let's say that if even if there are if we take another example, let's say that there are three servers here, right? Exactly like this, we have another server, so three servers, and just to keep the calculation simple, let's say that there are 600 users coming in. Okay, so what will we have? If we balance the load properly, we will have 200 users going to each one of the servers, right? So 200 each. So this is how we balance the load. So has to be a system which calculates the exact number of people who are coming in, and then it is distributing the users to the different servers. So it's not as if all the 600 users are coming in at the same time. They may be coming one by one, right? So the system has to keep a track of how many users are connected to each server. So let's say that there are 10 users coming in. So first it will distribute 3 to the first one, 3 to the other one, and 4 to the third server, let's say. Then there are three more coming in, so it will send one to each, right? So at any given point, based on the number of users who are connecting to the website, it will distribute equal number of users. So at any given point, if there are 90 users connected, it will ensure that there are 30 30 30 in each server connected. Okay, and that's why there is also a point where it is continuously connecting with the servers to ensure that there are equal number of users connected. So let's see what exactly is a load balancer. So from the definition, a load balancer is a device or a service which connects to the servers behind it, and it distributes the incoming traffic across multiple targets. Okay, so what is a target? What is a load balancer? That's what we are going to understand. So load balancer is a device or a service which accepts the incoming application or website connection requests, and then it will distribute it across different servers. Okay, so when we go on to advanced topics, you'll understand that in place of servers you can use other services as well, but at present we are focusing on servers. Okay, so the load balancer will pick up the request. So in this place, we will have a load balancer. Okay, so if these many requests are coming in, what will happen? We will place a load balancer here. This is what is called as a load balancer. So the load, so instead of the requests coming directly to the server from the internet, right? So this is the internet. So from the internet, the requests will come to the load balancer. That's how we will configure it. And we will see how to configure that so that the requests come and land to the load balancer. We'll see that later. So the requests from the internet come to the load balancer. The load balancer knows how many servers are connected to it, and it will distribute the equal number of servers to all the equal number of users connecting to the website to all the servers. So this is the role of a load balancer. Now, the load balancer accepts layer 7 traffic up. So that is the application layer traffic. So it accepts layer 7 traffic. All right, so and it distributes it. So let's see what's the second one. So there is a term called as a listener, right? So what is a listener? So we will configure it. So a listener is a rule that we create where we are defining a particular port where the connection request is coming. So I'll show that when I create that practical steps. I'll show that to you. So you create a rule where you mention this: if any request comes on this particular port, in terms of the internet traffic connecting to the website, if we are talking about port number 80, right, or 443, in this case we are not using HTTPS. We are for our demo we are just using HTTP. So we'll talk about port 80. So whatever request comes to port number 80, distribute to one of the servers, right? So that's what is a listener. So a listener is nothing but a rule. Okay, a rule or a decision maker based on a rule, right? So a listener is something which creates, which takes a decision based on a rule to send the traffic to the servers behind it. Okay, and what is a listener rule? That's what we discussed just now. So you can have multiple rules. If the request comes at this port, send it to this server. If the request comes at another port, send it to the other port, right? So to other servers. So these are the kind of rules that you can create, and putting together all these rules, you create, you have a listener, right? So we'll see how to work on that. So what is a target group? Now you can keep the targets or the servers within a group. So here, these are the servers, right? So these are my servers. So this is my server 1. This is my server 2, and this is my server 3. So these servers are nothing but the targets. Why are they called targets? But because this is where the incoming traffic is sent, right? So the incoming traffic is targeted towards the servers. That's why they are called as targets, right? So instead of server, I can also call it a target. So this is my target 1, this is my target 2, and this is my target 3, right? And because I want to keep them in one group, right? In many cases, it's also called as a backend pool. Because I want to keep them as one group, I call that group as a target group, right? Now, why do I want to keep them as a group? Because later on, we will see in another topic called as an auto scaling group, we will see that you can also remove and add new targets. That means new servers to this group. That's why we want to keep them in a target group. Okay, so what is a target group? A target group is nothing but a collection of targets. That means a collection of servers, right? So what we have understood is load balancer is the service or device which accepts the incoming request to connect to the website. Then it takes logical decisions based on something called as a process called as a listener, which works on listener rules. In the listener rule, we have mentioned any request coming in for port 80, right, which is accessing the website, just send it to any one of the servers in this target group, right? Send it to any one of the targets in this target group. So it will check which target has how many uh, active connections, and based on that it will distribute it equally. So if there are 30 incoming requests, it will ensure that all three have 10 each. So that is a target group, right? And register targets is nothing but the actual compute resources. That means in this case we have the 3 servers. These are called as the targets, right? And collectively they are called as a target group. Then we'll come to the health checks later. So this is what we are going to understand. How exactly does this happen? So we are going to create, we will create 2 servers, and then we will check how we can distribute this among the 2 targets. So how do we do that? So I'll quickly take you to our so we come to the AWS console. So I'll show it to you step by step. So on the AWS console, I have already created a VPC and the subnets, right? So we all know I cannot create any resource just on the fly, right? My resources have to reside somewhere. So my resources reside on the entire infrastructure, virtual infrastructure that I have created under something called as a VPC, right? Virtual Private Cloud. So within the virtual private cloud, I have created multiple sub networks as well. So virtual private cloud is the entire large network I have, and then within that we create sub networks, smaller networks, on based on which we can configure it as a public network or a private network, right? So if you give internet access to a particular subnetwork, it is called as a public subnet. So that's what we are going to see now. So our server, because it is going to accept incoming requests from the internet, we do need an internet gateway which will qualify our subnet to be a public subnet, right? So I'm going to show the present existing infrastructure. If you want to understand all this, the VPC subnets and everything, do check out the other videos. So first I click on my VPC. Okay, so this is the AWS console, and here I come to the VPC section. On the VPC section, if I click here, you'll see that I have one VPC which is called as the Mumbai VPC, and I have the CIDR block here, which I have defined as 10.0.0.0. So there are no filters applied right now. I have just one VPC because just for my personal reasons, I've deleted the default VPC given by AWS. I don't require it at present. So just to avoid confusions, I've deleted it. I only have one VPC which is created by me. So if you see here, this is not a default VPC. Okay, so is it a default VPC? No. This is the only VPC I have. So within this VPC, I've also created some subnets. So let me click on that subnet. See here, I have two subnets. One I have named as a private subnet. The other one I have named as public subnet. And these both these subnets are a part of the Mumbai VPC. So the only one VPC I have, within that I have two subnets. And if you see, both of them are part of the Mumbai VPC. And these are the CIDR ranges that they have: 10.0.1.0 and 2.0. All right. Now, if you see the route table, I do have two route tables defined. One is for the public subnet and the other one is for the private subnet. I do have one internet gateway as well. So here, this is the internet gateway I have, and it is attached to the Mumbai VPC again. So I have only one VPC. In that I have the internet gateway as well. So if you come to the route table, if I come to the private route table, I have only the default route. I do not have any other routes. If I go to the public route table, you'll see that I have the default route as well as I have a route to the internet, which is connected, which is going through the internet gateway that we have. Okay, so this is the present environment that I have, and now on top of this, we are going to build our load balancer infrastructure. Okay, so for accessing the load balancer, we go to our EC2 section. Okay, so the load balancer is accessed through the EC2 section. So I open that in a new tab here. Okay, so if you see here, I come to EC2, it says Amazon EC2. This is the main page, but on the left hand side, if you see, if I scroll to the bottom, you'll see a section called as load balancers. Okay, so I click on load balancer. Now there are different types of load balancers. Majorly, there is an application load balancer, there is a network load balancer. There are certain differences in terms of the protocols, which protocols they operate on. At present, we are going to focus only on the application load balancer. We'll see the network load balancer later. So I'll click on the load balancers. And if you see here, it says no load balancers. At present, I do not have any load balancers. It says elastic load balancing scales your load balancer capacity automatically in response to changes of incoming traffic. Okay, so I click on create load balancer here. And you see here, there are three different types of load balancers. One is the application load balancer, one is the network load balancer, as we had discussed. So application load balancer is the one which we are going to create. Network load balancer operates on a different types of protocols: TCP, UDP, TLS, all that. And we also have a load balancer called as gateway load balancer. This is mostly used in enterprise architecture, where you are creating different security appliances, and you are placing those security appliances like firewalls, etc., behind the load balancer. That is where we use a gateway load balancer. Okay, and that specifically works on GNU protocol, so that's a little more advanced. So we'll see that later on. So at present, we are going to focus on application load balancer. What is that? Choose an application load balancer when you need a flexible feature set for your applications with HTTP and HTTPS traffic. Today, we are going to focus only on HTTP traffic, through which we'll be accessing our internet-based application website. So we're going to use this one. So I click on create an application load balancer, and these are the steps that we are going to follow to create our application load balancer. So here, if you see, it says the application load balancer distributes incoming HTTP and HTTPS requests across targets such as Amazon EC2, microservices, and containers. So as I said, there are other targets as well that you can create later on, more advanced topics. But here we are going to use Amazon EC2 instances because we know very well about that so far. So when the load balancer receives a connection request, it evaluates the listener rules in priority order to determine which rule to apply, and if applicable, it selects a target from the target group for the rule action. So it will pick up the incoming request, it will check the port number, and according to the rule, it will forward it to the specific target group that we have. Okay, so let's see how do we create it. So here's the entire explanation. We are not going to go into that. We are going to see how to create the load balancer. I'm just going to give it a demo name. So let's say that this is my demo application load balancer. I give it a date, something like okay, let me just take demo ALB. All right, now there are two different types of load balancers here. First is the internet facing one, which we are going to create, where you can access the website over the internet, but there will be other possibilities of this being used in a network also, like internal load balancer. Maybe you have a corporate internal website or something which you are using only for your employees, where it's not connecting to the website, so not connecting to the internet or something, in that case you can use internal. But at present we are using a internet facing load balancer, so we'll click on internet facing. Okay, so we are using IP version 4. That's what we will stick to. We're not connecting with IPv6 at all. And it's asking me which network do you want to create this load balancer on. So as I told you, we have only one network, which is the VPC that I have created, which I already had. So I click on that, and you see I have only one VPC. So I select that VPC, Mumbai VPC, and I scroll down. And if you see, it says select at least 2 availability zones and subnet for each zone. A load balancer node will be placed in each selected zone and will automatically scale in response to traffic. All right. So what is it saying here? It's saying you need at least 2 availability zones. Why is that? Because if I create both the servers, even if I have 2 servers to load balance and I keep both of them in the same availability zone, then if that availability zone, that means the entire data center where I've created it, if that entire data center for some reason, for some rare reason it fails, then both my subnets will be impacted, both my servers will be gone. And how will you balance the load if you don't have any servers, right? So that's why, just to be on the safe side, it is recommended from AWS. In fact, it is mandatory that you should have at least 2 availability zones where your load is distributed among multiple servers. So in 2 availability zones, you can have at least 2 servers, but you can have more than that in case your server fails. Okay, so if you see, when I showed the subnets to you, I told you that I have only 2 subnets. Both of them are in different availability zones. See here, 1A, 1B. They are in different availability zones, but one of them is private. So let me create another public subnet just to ensure that I have 2 public subnets, okay, because both of them will have to be connected to the internet. So I need another public subnet. So my public subnet is in 1A, right? So I'll create my other public subnet in another subnet. Okay, so I'll create my public subnet in another availability zone. So I click on create subnet. I select the VPC. So I'm creating another public subnet because it is mandatory for the load balancer to be working with 2 public subnets if I'm using a public load balancer. So I say public subnet 2, and I select a different availability zone, and I give the IP range as 10.0.3.0/24 because I already have 10.0.1.0 and 2.0. So I'm using 3.0 so that there is no IP conflict. All right, that's it. I enter these details and I click create subnet. Okay, so whenever we create a subnet, by default, we all know that it is by default a private subnet. How does it become a public subnet? It becomes a public subnet when you connect it to the internet. Okay, so what do we need to do? We need to create a route table which is which has a rule which connects it to the internet. Or what I can do is, I have an existing route table which is the public route table. I can associate this with the other subnet also. Okay, so I open the public route table. See here, public route table. I come here and I associate it. See here, subnet associations. I just come to edit subnet association and I associate it with the other public subnet as well. Okay, so I connect it with both the public subnets. So what does that do? Because I associated it with both the public subnets, now these routes are applicable to both the subnets, right? So when I come to the routes, I see very clearly that I have an internet route as well here. Okay, so both my public subnets now have internet access. If you see the private subnet, if I go to the route table, it does not have access to the internet. But now if I go to the subnet, public subnet number 2, if I go to the route table, it will have access to the internet. Why? Because I've connected to the route table which has access to the internet. Okay, so that's our entire setup. Now I come back to the same page. If I come to the other tab where we were creating the load balancer, so we'll go from the first step again. So what did we do to create an application load balancer? I give it a name. I select it to be an internet facing load balancer. I select it as IPv4. I select the VPC in which I want to create it. Then I just refresh it. Okay, and once I refresh it, see here, earlier it was showing only 2 availability zones. Now I created another subnet and I added it to the availability zone 1C, right? So that's why now we are able to see 3 availability zones. So I want to select both these. Why? Because I have my public subnet here and I have my other public subnet here. So if you see here, my public subnets, both my public subnets are in 1A and 1C. Okay, 1A and 1C. So let me select 1A and 1C. Okay, so these are the 2 subnets that I want to select. Right, then I come to the security group. Here I want to just create a security group where I want to ensure that has access to the internet. So let's see if it gives me an error or something. We will ensure that we add the rule group necessary for that security group, okay, later on. So right now we've selected the VPC, we selected both the subnets, and we selected the security group. So we know the security group is the one which allows different traffic protocols to enter into the load balancer and the server. Okay, so this is the listener group that we had discussed. So this listener is what actually processes the request whenever a user over the load balancer is trying to connect to the website hosted in the servers. First, it passes through here. So here, a listener is a process that checks for connection requests using the port and protocol you configure. The rules that you define for a listener determine how load balancer routes requests to its targets. Okay. So now what have we done? We are going to create a listener rule. So we are going to say any request which comes to port number 80 should be sent to this target group. Which target group? This one, right? So any request, so let me highlight it here. Any request over the internet which comes to the load balancer for port number 80 should be sent to this target group, right? It should be sent to this target group, but the load balancer determines at any given point in this target group which server should it be sent to. So it will ensure that the load in all the 3 servers are equal. So based on that, it will take a decision on which server it should be sent to, but it will definitely be sent to this target group, right? So that's the um, rule, that's the listener that we are creating. But the important question now is, do we have this target group yet? Have we created the servers yet? We have not, right? So what do? We have to create a target group. So if you see, there is no path where I can send it. At present, I do not have any target group. Even if I refresh it here, I do not have any target group. So what do I need to do? I need to create a target group, right? So I click on this, which will bring me to a new place here. So I just create a target group. I'll say that in my target group, I need instances. So what will be the instances? The servers that we will create in a while. Okay, so I just create the target group right now. So I say instances, that's it. I give the target group a name. I'll say demo TG target group, and these are the protocols. And I again select the VPC. So it's a very simple process. And health check is something that I will discuss a little while later. So we keep the health checks as it is, and then that's it. Okay, so to create a target group, what are we saying? In the target group, I will later on add my instances. That means I will add my servers. I won't add any other functions, which we can. Then I give a name to my target group. Then I set the protocol exactly the way that we are doing in the load balancer also. Then I select the VPC. That's it, right? And health check we will discuss a little while later. That's all. And I say next. And then here it is asking us to add the servers. At present, we have not created the servers, so we can just leave it as it is. And we can add the servers a little while later. So I click the create target group. That's it. And my target group has been created. Okay, so what have we done so far? we have created the target group. Okay, servers are not yet created. So I come here to the other tab again, and if I see, earlier we did not have the target group. Now I refresh this, and you see I have the target group here, right? So we have the load balancer. Now we have created the target group as well. Now I scroll down. These are some other services that you can attach to your load balancer. You have some web application firewall, some CloudFront distribution, etc. But we are not going to use that at present. So I just click on create load balancer. So these are the steps that we have performed. We have made it as our internet facing one. We've added the subnets that we want. We've added the security group. We created a listener where it is pointing to the target group. And now we are going to create the load balancer. So once we create the load balancer, what is remaining? So here, see, we are going to create the load balancer right now. So we'll create the load balancer. We've created the target group. Once this is done, all we have to do is create the servers, right? So we'll create the servers, and then we will add the servers to the target group. Once that is done, we will be able to do our testing, right? So what do? I just click on this create load balancer, right? And it says successfully created load balancer demo ALB. And if you see, at present, the status is provisioning. So while this is provisioning, what we will do is we will create our two servers. We'll create our two EC2 servers, and then we will add those servers to the target group, and then that will be done, and we will check how we can connect to our website hosted on the servers through the load balancer. Okay, so our next step is to create two EC2 servers. We'll create Windows servers so that we'll be able to understand how to do it. We'll create two EC2 servers, and then we will create a sample website on it, just a basic HTML website on it, and then we will add it to the target group, and we will see how we are able to connect to them through the load balancer. All right, so now let's create our two EC2 servers. So I just click on EC2. Now we're going to launch two servers. On both the servers, we will ensure that we log into them, and we will create our web servers. We'll create a sample website on them, and then we will add it to the target group. Okay, so I click on launch instance, and I just say demo server, or I'll call it web server. Okay, so we can create two of them. So I select Windows 22 base. Then I scroll down. We know very well how to create a server, so I'm just going to go a little faster here. So I'll just say to ensure that our server runs quickly. You know, it's a little fast. I'm not going to take T2 micro, but if you are practicing, please ensure that for you to spend some good amount of time, just ensure that you take T2 dot micro, because that is the only free tier server we have. But at present, for my server to run a little faster, I'm just taking, let's say I'm taking T2 dot large, right? That's it. Now I'm going to just create a key pair. So let's say that I create a new key pair. So I'm just going to say demo load balancer key. So something like this. Then I create the key pair. That's it. Now here I'm already I've selected Mumbai VPC. So I'm going to create one server at a time. All right, I'm not going to create both the servers together. I'm creating one server at a time. What is the reason for that? Because I want to place both the servers in different subnets, right? So the first server I'm going to place in the Mumbai public subnet 1, right? And should I auto assign the public IP or not? We should, right? Because I'm going to connect it to the internet. I'm going to access it through the internet. We are going to host an application or a website on it, which we will access through the internet. So I do need internet access on it. That's why I am going to assign a public IP address to it, right? That's it. Now I come down. I'm going to create a security group in which I'm going to allow RDP, and I'm also going to allow HTTP. right? Let's allow another rule ICMP also in case we need to ping and check something. So I've added 3 rules here. That's my security group. That's it. So our first server is ready to be launched. So I click on launch instance. Okay, so if I go to instances, my instance is being launched. I'll just copy this name. And now we will create the other server, second server. So I'm going to click on launch instance again. I put that name here and I say 2. I select Windows and I'll select the computer base. Again, I'm going to select here t2.large. I'm going to use the key pair that I just created. Okay, then I come down. I'm going to use the other public subnet that I created. So Mumbai VPC Mumbai subnet number 2. And as we discussed, we do need internet access. So I'm going to say auto assign public IP. And I'm going to select the security group that we just created. So I'm going to allow HTTP here. That's it. And now we're going to launch this instance as well. So both my instances are being launched. Okay, so this type is not available here. So I'll just select something else. And I launch the instance. Right, so both the instances are now coming up. Once it starts running, I will access it and we will install the IIS server service from the Windows Server manager, and then we will create a demo website on that. So right now both the instances are initializing. Once they are up, we will log into both the servers one by one and do the configuration. So we can see that one of the servers is now up. So while the other one is coming up, let me connect to this server and create the IIS web server. All right, so we have the credentials here. I'm just going to get the password. So I upload the file. So I enter the password here. And the server is now coming up. So this is the first server which is coming up. Let's see if the second server is also up now. Okay, so the second server is also up. So I'm going to select this server, this second server, and I'm going to connect to it. So we'll get the password as well. So we've seen this process already. So I just enter the password here. So if you're not aware of how to connect to an EC2 server through the RDP, just make sure you check out my my EC2 video. You'll get a very good idea how to access it. Okay, so here we see both the servers are now coming up one by one. So on both these servers, now we will access the server manager and then we will connect to the IIS server. We'll enable the IIS server and we will create a sample website. Okay, so I'm just opening up the first server here. This is my first server. On this, I'm going to, once this is up, I'm going to add the IIS server feature. So if you see here, the IP address is clearly visible, 13.235.45.201. This is our public IP address of the server. All right, so if you see now we are on the installation page where we're going to install the particular feature that we want. For in this case, we want the IIS feature. So I just scroll down from the very bottom. If you see the third one towards the top, the third from the bottom, this is the web server IIS. I select that and I say next. We are not going to install any other feature. So I just say next and I'm going to say install. Right. So while this is installing, we know that the inet pub. In the inet pub folder in the C drive, we will get the required file here. So let this install first. Let this feature get installed. In the meanwhile, in the other server also, we will initiate this request. Okay, so this is the second public server that I have. Here also, I'm going to install the IAS role, web server role. I'm not going to add any other feature. Okay, so in both these servers, the required IAS role will be installed. So this is the first server again. So we have both the servers here where the installation is ongoing. So once this installation is over, we will go into the root folder, the inet pub folder, and then there we will have the www root file. There we'll just create a test file, and then once that is done, the server will start hosting that particular test website. Right. So I just maximize this. Now I go to the www root file folder. Now let's just create a sample file here. Okay, and I'm going to save it. So I'm going to say this is my test server 1. All right, and this is what I'm going to say, and I'm going to save it as all files. I'm going to name it as index.html. Right, so this will ensure that this will come up when we are accessing our web server. Right, so this feature is done. So this is our first server where I've completed the process. Now I go to the second server. So I do the same thing. I go to inet pub, I go to root, and here we just create a sample. This is okay. So just let me just copy that from here. So I just want to show to you that it's very simple. Okay, so I just put that here and I call this as 2. All right. So just to know that we are able to identify it. So I name this as index. So why are we doing this? Because we need to ensure that we are able to identify that we are connecting to both servers separately, right? That's why we've done. So on the server number 1, see here on 45.201, right? I have mentioned this is my test server 1, right? And here on 94.60 ending IP address, I mentioned this is my server number 2. Right, so these are the two servers that we have. So I minimize both. Right, I've minimized both. I've configured the web server on them. We put the test website HTML file there. Now, according to what we have already learned in our EC2, we know that if I access this server with its public IP address, I should be able to pull up that public page. Right, so if I put that here, see here, it says this is my server 2. Similarly, if I use the first page, right? If I put that here, see here, this pulls up my test server page 1. So we have server 1 and server 2. So we have both our servers up and running now. Now, through the load balancer, we are going to check when the different users are coming in. Is the load balancer distributing those user requests equally to the different servers, right? So we have two servers which we are now connecting to the load balancer. So how do we do this? We now connect both the both the servers to the load balancer target group, right? So if I go back to the diagram, you'll see that we are not using this server. We've created only two servers. So I'm removing this. So we've created the load balancer, we've created the target group, we have created both the servers now. Both the servers now are being connected to the target group. All right, so how do we do that? I go to my EC2, and here I go to see here under load balancer you have the target group. Okay, so I click on target group, and I have only one target group. I go to this target group, and if you see, I have this option to register the targets. Okay, so if I click on register targets, you see it is showing me all the available instances that I have. That means all the available servers. Right now I have only 2 available servers. If I had 10, it will show 10. If I had 100, it will show 100. Right, so right now I have 2, and I'm selecting both. So I select both the servers, and I click on include as pending below. So I've added both of them, and now I click on register pending targets. So first I can just select them and add them, but now I have to click on register. So when I click on register, see, both the targets have been registered to the target group. So ultimately, if I go to the diagram, see, both these targets have now been successfully attached to this target group. So both these targets, both my servers are in my target group. My target group is connected to the load balancer, and the load balancer will accept requests from the internet. Okay, so this is how our entire setup is at present. So let's check. Now, if you see, if I refresh this entire page, it tells me that both these servers are healthy, right? Why is it saying they are healthy? The reason for that is something that we had checked when we were creating the load balancer. We had an option called as health check, right? So what is this health check? The health check is where the load balancer continuously sends a request. It's called as a hello request, right? It sends a hello request to the server, and it just gives them a call saying, hello, are you okay? Are you able to function? Are you able to, are you ready to take requests that I send to you? It keeps checking with them every now and then, right? You can set the time, how many times you want to check, at what frequency you want to check. So it will keep asking the servers, are you okay? Are you able to? So let's say that in case a server is fine, it's working every now and then, I mean, it's working continuously, then when the load balancer asks the server will say, yes, I'm absolutely fine, I'm functioning absolutely fine. You send whatever requests you have to me, and I'll process it, right? But in case, let's say that for some reason the server shut down, for some reason there is some conflict in the application or something like that, then when the load balancer asks the server, are you okay, can you take requests, then the server will say, it will not reply at all. Okay, it will not reply. So if it does not reply, there is a certain condition. So see here, 5 consecutive health checks, and at an interval of 30 seconds. So every 30 seconds, the load balancer will send request to the server asking, are you okay? So let's say the server does not respond. Then after 30 seconds, it will ask again, are you okay? Same way, it will do it 5 times. See here, health check, 5 consecutive health checks. So that means 30 multiplied by 5, that means about 2.5 minutes. If the server does not respond at all, it will mark that server as unhealthy. When it marks the server as unhealthy, see here that unhealthy will become 1. Right? Then what will happen? The load balancer will stop sending any traffic, any user to that particular server, because that server is not available, right? So if it sends any user there, they'll not be able to see the web page. That's why, just to avoid it, it will stop sending traffic to that server. So this is what is a health check. Now, you may think that, then in that case there will be only one remaining server, right? That's not the case. That's just only in case of this demo, right? So in the real world scenario, you'll have 10, 15, 100 servers. So in that case, if there are 1 or 2 or 3 servers go down, it's not a big deal at all. If there are 100 servers, 2 or 3 servers are not working, the load balancer will check with them. If they don't respond at all, it will mark it as unhealthy. So there will be 97 healthy servers, 3 unhealthy servers. It will stop sending traffic to them. Let's say after some time the servers come up, right, and this load balancer will keep checking, then it will mark them as healthy again, right? If you want to be, if you have some critical websites or something, you want to mark them as unhealthy very quickly, then you can go into this edit section. You can even say health threshold as 2 times. So it will just check 2 times in every 30 seconds, and if it does not respond, it will mark it as unhealthy. You can even reduce this 30 seconds to 15 seconds, 5 seconds. Go into edit and you can do that. Okay, so that's health check. So that's what, when we connected our servers to this target group, it marked our servers as healthy, right? So now what have we done? We have created our load balancer, we have created our target group, we created our targets, which is the servers, and we have added our servers to the target group. Now all this is connected. So when my request comes from the internet to the load balancer, it will send the traffic to both the servers one by one. Okay, so how do we check that? So I need to go on the left hand side, on the EC2 page. On the left hand side, you see I have load balancer. I click on load balancer. So I have one load balancer. So if I click on that, you see it is sending all the requests. See, this is the load balancer we have created, application load balancer. It is showing as active. It is under this VPC. Okay, these are the two subnets under it. Now if I go to listeners, it has one listener which we have configured. Any request coming on port number 80 will be sent to this particular target group, right, which is target group that we just created, right? And if I open this target group, you'll see that in this target group we have two servers, the two targets that we have created, demo web server 1 and 2, right? So I go back to the load balancer tab again, and here now how do we access the load balancer? That is the important key, right? So we access the individual servers one by one, but now I don't want to access the individual servers one by one, right? I want to access my load balancer. So how do I do that? So on the load balancer page here, see the load balancer page, there is something called as a DNS name, right? So this DNS name is assigned to my load balancer by AWS itself, right? So it is auto generated. So now if I click on this DNS name and I open it on my browser, it should automatically, it will send my request to the load balancer, and via the load balancer it will send me to one of the target servers, right? The only condition is on my security group. Let's just check once whether my HTTP is allowed or not. Okay, so HTTP is allowed, so it will go in. Okay, so I copy this load balancer's DNS name here and I put it on my browser and I access it, and you see it immediately directs me to one of the servers behind the load balancer, which is in the target group. So it has, because this was a fresh request, it has sent me to any one of the servers, right? Now if I refresh this, it will treat it as a separate request and it will send me to another server. So if I refresh this, you see it sends me to server number 1. Now if I refresh it again, server 2, server 1. So this is how, if there are multiple people coming in, the first person it will send to server 1, if the second person it will send to server 2, so on and so forth. So if there are 10 servers, each person it will send to one by one server, and then henceforth again from 11th person onwards it will send to all the other servers again. So that's the way that it balances the number of people connecting to the website on all the different servers. Now here, just for us to identify which server it is connecting to, I had mentioned on both the servers, I had mentioned server 1 and server 2, right? Just for our understanding. But in the real world scenario, all the 10 servers will have the exact same website content, right? So when they have the exact same website content in all the 10 servers, irrespective of which user is connecting to which server, they will all see the same website, right? And how to ensure that all the 10 servers will have the same exact content? For that, we will see that in the upcoming session in a topic called as auto scaling group, right? But in this case, just for our understanding, we had kept it as server number 1 and 2, just like we configure each of the server. This is how you configure the different servers. So if you have 10 servers, 20 servers, all the servers will be configured with the same website content, and based on how many users are connecting, they'll be connecting to different servers in the backend target pool, and they will see the same content hosted on each of the websites. So this is the entire concept of a load balancer, because you cannot rely on just one server or even 2 or 3 based on the incoming capacity of traffic on your website, you need multiple servers. And how do you manage traffic to the different servers? You manage it through load balancer. So in this case, we have seen an application load balancer where we are hosting a website, but you do have the network load balancer as well, and for different security devices you have a gateway load balancer as well. So I hope this topic was very useful for you. This is one of the most important topics in different interviews. If you're going for an interview or something, they'll definitely ask you what are the different types of load balancers in AWS, and what is the exact use of a load balancer. So if you are able to explain to them why a load balancer use along with the real world example in case of a e-commerce website or something, or some different results-based websites where a particular student or college results are being announced, where on a particular day or a period there is a higher number of incoming user requests. In those cases, definitely a load balancer used. And so this is an important topic for interviews as well. So make sure you learn this well. And thank you so much for watching.